Hi everybody, Darren back here again at Camosun Pipe Trades in the Cross Connection Control Lab, and today we're going to be testing the pressure vacuum breaker assembly. So I have a 5 valve differential gauge again, and I've removed the high side and bypass hoses as we don't need them for this test. And I also have the gauge hanging about center line of the assembly or within a gauge width. So that's the position I want to be in. And I'm going to remove the canopy before I start the test. So I'm going to notify, identify, inspect, and observe, and request that water be shut off at the time of the test, and then I get permission to do that. So before I start the test, I'm going to quickly flush the test valves, number 1 and 2. And once I have those flushed out, I can attach my high side hose to test valve 2. So we're going to get ready to test the air inlet valve and its opening point. Making sure all my control valves are closed and bleed valves. I'll slowly open the test valve 2 and bleed the gauge through the high side bleed. Once I have all the air out of the hose and gauge, I can close the high side bleed and isolate the assembly. Close number 2 and then number 1. Okay, now I'm going to throttle the pressure out of the body of the assembly, and I need to accurately verify the opening point of the air inlet valve. So I usually like to rest the back of my hand on the valve while I look at the gauge face, because we need to accurately get this point where the air inlet valve opens. So as we bleed water out, I throttle the bleed valve back in so that we can slowly and accurately count down the pressure reading on the gauge. And we're expecting an opening point somewhere around 3 or 4 pounds. So slowly throttle back in. 4.2, 4.0, 3.8, 3.6, 2.8. 2.8 PSID is when the air inlet valve opened. So 2.8, I record on my test form, opened at 2.8 PSID, which is a pass, it was above 1. And then we want to make sure that the body drains fully. Sometimes what I like to do is remove the high side hose from the gauge and drop it below the level of the valve body to fully drain the valve. We look in to make sure that the valve is free from the seat. Reattach my high side hose to the high side port on the differential gauge. Sometimes carry a sterile instrument that can be used to determine if the valve is fully open. Okay, so now that I've tested that opening point, I can remove my high side hose from test valve 2. Make sure that I close test valve 2 before I recharge the valve. So to recharge the valve, I have shut off 2 closed, and then I'm going to quickly open up shut off 1 to seat the air inlet valve. Once that's reseated, I can attach my high side hose to test valve 1. Getting ready for the second test, which is verifying the check valve in the PVB for tightness in the direction of flow. Should be 1 PSI. Going to slowly open test valve 1 while I bleed the gauge through the high side bleed. Once we're satisfied we have all the air out of the gauge, we can close the high side bleed, isolate the assembly, and then we open up test valve 2 to drain the body. You'll hear the air inlet valve open. It's going to take a few moments for the residual water to get past the check valve. And again, just like the double check valve assembly, we're looking for a 1 psi minimum, steady gauge reading for 2 minutes. So for the purpose of my demonstration, if we were satisfied that it didn't move for 2 minutes at 2.6 psid, we would record that as the check valve tension. So I've got check valve closed tight, 2.6 psid, and we've completed that part of the test. So now we're going to take the static line pressure at the time of test. Just going to close test valve 1 and 2 and recharge the valve by opening shutoff 1 quickly. Open up the test valve 1 and bleed the gauge one more time. Once the air is out of the gauge, we can close the high side bleed and record the static line pressure at the time of test, 40 psi in this case. Once we record that, close the test valve, remove the hose. Wipe down the assembly, and just before we put it back into service, ask for permission to turn water back on. And replace the canopy on the assembly. And that concludes our test of the pressure vacuum breaker.